Welcome back. This is the third lesson recording for IM2, March 15, 2021. Where we left off, we were doing this problem, 5 to the power of 3 over 2. We can represent 5 to the power of 3 over 2 as 5 to the power of half, all raised to the power of 3, because half times 3 is 3 over 2. Or we could represent that as 5 to the power of 3, all raised to the power of half, because 3 times half again is 3 over 2. Alright, so in this case, what do we have here? This is same as 5 to the power of 3 and then taking a square root of it. So these two, they are both valid interpretation of 5 to the power of 3 over 2. Depending on the numbers, sometimes one will be more advantageous than the other. And we will see that in some of the Desmos activity. Okay, what about this? This is in radical form. We want to find convert it to the exponent form, and so this is same as 2. So what's inside is 2 to the power of a third. What's inside the parenthesis is 2 to the power of a third, and then whatever that is, it's all raised to the power of 2. So this is same as 2 to the power of 1/3 times 2 is 2/3. With that, you're going to try card number 10 to 14 of Desmos activity. And then you can, once you're done with that, you can continue with card number 15 to 17. As you're doing it, I am going to show you a slide of laws of exponents. This is the product rule. When you are multiplying two numbers with the same base, then you can just add the exponents. The or quotient rule, when you are dividing the two exponents with the same base, exponential expressions with same base, we can subtract the numerator minus the denominator exponent. Or this is the power rule, x to the power of m all raised to the power of n. You multiply the m times n, and x to the power of 0, anything raised to the power of 0 is 1. X to the power of -1 or any negative, you take a reciprocal of whatever you are raising it to. Okay, so what is a reciprocal of x? That's 1 over x, and then it's to the power of 1, and x to the power of m divided by n now is the numerator exponent is what is being raised to the power of. The denominator exponent is the root index. So you want the nth root of what you are raising it to the power of. Okay, so what is 9 to the power of half? This is same as 9 to the power of 1 and taking a square root of 9, isn't it? So 9 to the power of half is same as square root of 9, which is, and whenever you can simplify it, you simplify it. Okay, so square root of 9 is just 3. So this is same as square root of 9. Alright, what about this? 64 to the power of 1/3. 64, that means this is same as third root of 64. So it is same as third root of 64. Notice when I write third root, I write it as a little letter on top of the square root sign. Okay, so that should not be confused with 3 root 64. It should be really clear to you yourself that this is a third root, while this is 3 multiplied by root 64. Okay, so do not get the notations mixed up. They are not the same. Okay, so then what we're looking for is what number multiplied to itself 3 times is 64. That is what it's asking. Well, 4 to the power of 3 is 64. So I know that this is equivalent to 4. Okay, two ways of writing 5 to the power of 3 over 2 using radicals. Well, I can represent this as, first I can raise this to the power of 3 first, and then raise it to the power of half, because that's 3 times half is 3 over 2. Or I can raise 5 to the power of half, raised to the power of 3. They are both valid interpretation. Okay, this will be 5 to the power of 3. What's inside the parenthesis is 5 to the power of 3. And then whatever that is, you're taking a square root of. The second one is you're taking a square root of 5 and then raising that to the power of 3. So they're both valid. This time we're being asked to rewrite square root of 7 as exponents. Okay, so this is in radical form. We want to convert that to exponent form, that is same as 7 to the power of half. Now we want to write this expression in exponent form. Okay, so currently it's in radical form. What's happening? This is 11. Oops. What's inside the radical sign is 11 squared, and then it is being third rooted, which is same as being raising it to the power of a third. So that is same as 11 to the power of 2 over 3. Okay, this is a challenge problem. Now we're being asked, what does this mean? It's negative 64. Oops. That's negative 64 is being raised to the power of 64, which is same as taking a cube root, or third root, which is same as cube root of negative 64. So what it is asking is, what number multiplied to itself 3 times is negative 64? Well, I know that if it's, say, x times x times x is positive 64, x is 4, because 4 times 4 times 4 is 64. What do you think is the number that would give negative 64 when you multiply 3 times? Hopefully you're telling me it is negative 4, because negative 4 times negative 4 is positive 16. Positive 16 times negative 4 is negative 16. So you can take a cube root of negative number. This is not 4i. This is not 4i. You can take when you multiply a negative number to itself 3 times, you do get negative number. So unlike square root, where you cannot get a negative number, with cube root, yes, you can get negative number. So the correct answer in this case is negative 4. Okay, this time we are asked to evaluate negative 64 to the power of 2 over 3. Okay, so we've just evaluated that negative 64 cube root was negative 4, right? Because negative 4 times negative 4 times negative 4 is negative 64. Now what's the difference here? The difference here is the 2 as a numerator, the top fraction number. So this is really same as, I can think of this as negative 64 to the third root. Okay, I'm applying that first, square, because this is same as negative 64 to the power of a third to the power of 2, which is what I am doing here. Okay, so, and I've just said that this is same as negative 4. What's inside the parenthesis is same as negative 4. So that's same as negative 4 all squared. And negative 4 all squared is negative 4 times negative 4. That is positive 60. So the correct answer is 60. Last question. 81 over 25 all raised to the power of 3 over 2. Okay? Alright, now one way to get rid of this negative exponent is to flip whatever is being raised to the power of. Okay, so if it's a fraction, you just flip it. So that just becomes same as 25 over 81. All raised to the power of, we've just taken care of the negative exponent by flipping it. Now that is over 3 over 2. You do not flip the fraction, or the exponent fraction. You've just flipped what the base fraction. Okay, so in this case, what is this same as? This is same as 25 to the power of 3 over 2. I can apply this separately, and 81 to the power of 3 over 2. And I can think of this as 25 to the power of half, then raised to the power of 3, and same thing, 81 to the power of half, raised to the power of 3, which is same as 25 square root of 25, all raised to the power of 3, and 81 square root of 81, all raised to the power of 3. What is square root of 25? That's 5. Now we're raising it to the power of 3. And what is 81? Square root of 81? That's 9. And then 9 is being raised to the power of 3. So that is 5 to the power of 3 is 125. And 9 to the power of 3, that's 81 times 9. That's 700. 81 times 9. That will be 729. Okay, so that your final answer is 125 over 700. And that is it for today. So as on your table of content, what we covered was fractional exponents. Thank you for listening.